Welcome to my new lecture. Today we will solve exercise 7.1 from unit 7th coordinate geometry. Starting with the first question, we need to find the distance between each pair of points. Now you should know the formula of distance, which is square root of x2 minus x1 whole square added with y2 minus y1 whole square. In the first part, we have minus 2 comma 1 and 1 comma 5. So how can we find the distance of these both points? If you look at the first coordinate, we will consider the first part as x1 and the second as y1. And if you look at the second points, we can consider the first as x2 and the second as y2. So if we subtract x2 with x1, take the whole square of that and add that with y2 minus y1 and also taking the whole square of that. So we will get our formula of distance. How can we do that? Firstly, let's take x2, which is 1 in this case, and subtract that with minus 2. Now we need to find y2 minus y1 whole square. So we are going to subtract 5 with 1, take the whole square of that. So now 1 minus minus 2, that is 3. 3 square plus 5 minus 1, that is 4, so 4 square. Now 3 square plus 4 square, that is 9 plus 16. So you're going to add them up. We get under root 25, and that means our final distance is 5. So that is how you find the distance. Moving on to the second part of question number 1, we have 1 comma 1 and 7 comma 9. Again, we will follow the same steps. We will first write 7 minus 1 whole square added with 9 minus 1 whole square, and then we're going to take the square root of that. So 7 minus 1 is 6 square and 9 minus 1 is 8 square. Simplify that, that is 36 plus 64. Add them up, that is under root 100 or square root of 100. So your distance will be 10. Okay, moving on to the third part, we have 0 comma negative 5 and negative 2 comma 1. Okay, what are we going to do now? Firstly, we will subtract x2 with x1. So minus 2 minus 0 whole square added with 1 minus bracket minus 5 whole square. That gives us 4 and 36. 4 added with 36 is under root 40. So the under root 40 is 2 under root 10. So this is your distance. Then in part number 4, we have 4 comma negative 1 and 2 comma 0. How are we going to find the distance? By using the same series of steps. 2 will be subtracted from 4, take the whole square of that, add that with 0 subtracted from negative 1 whole square. We get 4 plus 1, which is 5. So we get 2.23. That is our distance for these pair of points. Now in the last part, which is part number 5, we have negative 3 comma 1 and negative 2 comma negative 3. Firstly, negative 2 will be subtracted from negative 3 whole square added with minus 3 minus 1 whole square. So we get 1 added with 16, that is 17. So if you take the under root of 17, you get 4.12. So this is how you can find the distance between each pair of points. Here we are given 3 points, which is 0 comma 1, 2 comma 3 and 3 comma 4. What do we need to exactly do here? We need to check by the distance formula whether these points are collinear or not. So a simple principle is to know that the first 2 points, which is AB, and the last 2 points, which is BC, if you add them up together, they should be equal to the first and last point, which is AC. So look, I have the first coordinate, let's call that A, the second as B, and the third as C. So firstly, I will find the distance of the first 2 points, which is AB, then the last 2 points in BC. And then I will find the distance of the first and last point, that is AC. And then I can check whether I add the first 2 points and the second 2 points and they are equal to the first and last point. So that if they are equal, then you can conclude that yes, by using the distance formula, these points are collinear or not. Looking at the first 2 points AB, we can find their distance by using the same formula, the same method that we used earlier. We can say 2 minus 0 whole square added with 3 minus 1 whole square. Take the under root of that. So we get 4 and 4. Add them up, we have under root 8, and that is equal to 2 under root 2. Now we are going to find the distance of B and C, which is the last 2 points. So that will be 3 minus 2 whole square added with 4 minus 3 whole square. So 1 gets added with 1, we get under root 2. Okay, so we found the distance of the first 2 points and the distance of the last 2 points. Now we will find the distance of AC, which is the first point 0, 1, and the last point, which is 3, 4. So let's see what is the distance of that. So we wrote distance of AC, that is equal to 3 minus 0 whole square added with 4 minus 1 whole square. So 3 square is 9 and 4 minus 1, that is also 3 square. We get 9 plus 9, which is 18. So the distance of AC we are getting is 3 under root 2. Now we know that this is the actual value of the distance of AC which we just found. But we still need to check whether if we add the first 2 points, which is the 0, 1 and 2, 3, their distance with 2, 3 and 3, 4. And if it is still equal to the distance of AC that we found, then we can conclude that these 3 points are collinear, which means they lie on a straight line. So let's check whether they are collinear. We wrote the distance of AB plus the distance of BC is equal to 2 under root 2 added with under root 2. So now distance of AB added with distance of BC is 3 under root 2. So if you look closely, you will notice that they are the same. That means that all points are collinear, and we just proved this question. Now moving on to the second part. This is also the same as the above question that we just attempted. Let's take the first as A, the second as B, and the third as C. So we are going to again find the points of AB, BC, and then AC. After that, we will add and check whether AB and BC get added with each other, and that gives us the distance of AC. Firstly, the distance of AB, what will that be? That will be the distance of the first 2 points. So 1 minus bracket minus 5 whole square added with 0 minus bracket minus 4 whole square. After that, 36 gets added with 16. That gives us 52, or 2 under root 13. So that is the distance of AB. Now let's find the distance of BC. So that will be the last 2 points. So that is 6 minus 1 whole square plus 7 minus 0 whole square. We get 25 plus 49, which in total is 74. So the under root of 74 is 8.60, or just leave it as it is. Now we are going to find the distance of AC, which is the first and last point. So 6 minus bracket minus 5 whole square gets added with 7 minus bracket minus 4 whole square. So we get the squaring of 11 added with the squaring of 11, which is 242, as the squaring of 11 is 121. So the final answer that we get for the first and last point, the distance is 11 under root 2, or 15.55. Now this is the actual value that we just found. But we need to check whether we add the distance of AB and the distance of BC, and they're still equal to this 15.55. So I added them up, and they were still equal to 15. Hence this is also proved that these points are collinear, they lie on a straight line. Now in the last part of this question, if you look, we have 0, -5, 3, 7, and 5, 15. We will again follow the same series of steps. So the distance of AB, which is the first 2 points, that will be 3 minus 0 whole square added with 7 minus bracket minus 5 whole square. Then we will take 9 added with 144, that is 153. So simplify that, the under root of 153 is 9 under root 17. Now we will find the distance of BC, which is the last 2 points. We will write 5 minus 3 whole square added with 15 minus 7 whole square. So that gives us 4 added with 64, that is 68, and under root of 68 is 2 under root 17. So we found the distance of AB and BC. We just now need to find the distance of the first and last point. So that will be 5 minus 0 whole square added with 15 minus bracket minus 5 whole square. So we get 25 plus 400. Taking the under root of that, our final answer is 5 under root 17. So we just got 5 under root 17, which is the actual distance. But let's check whether the distance of AB and its sum with the distance of BC is still equal to 5 under root 17. Okay, so I added them up, 3 under root 17 with 2 under root 17. So 3 and 2 gets added with each other, and the under root 17 stays the same. So we get 5 under root 17. So that means, yes, that our points are still collinear. This proves that. Okay, now let's move on to question number 4. In question number 4, we need to show that these vertices A, B, C, and D, they are the vertices of a square. So in order to prove that they are the vertices of the square, all of their sides should be equal. This means all of the lengths that we are going to find, they should be equal with each other. So in order to prove that, we will first take the distance of AB, then the distance of BC, and then the distance of CD, and at last we can take the distance of AD. Then we will know that yes, if all of the values are the same, then they are in actual the vertices of a square. So firstly, we will take the distance of the first 2 points, which is A and B. So that will be 1 minus bracket minus 4 whole square added with 4 minus 2 whole square. So that will be under root 25 plus 4. We get under root 29 or 5.38. In the second, finding the distance of BC, we have 3 minus 1 whole square added with negative 1, negative 4 whole square. So we get 4 and 25 again. Under root of 29 is still 5.38. So far A and B and C, their lengths are the equal. Now we need to check if the length of CD and the length of AD is equal, then we can conclude whether this is a square. So the distance of CD, point C and D, that is negative 2 subtracted from 3 whole square added with negative 3 subtracted from negative 1 whole square. So 25 plus 4 is under root 29 and under root 29 is 5.38. Now we need to check the last, which is A and D. So minus 2 subtracted from negative 4 whole square added with negative 3 minus 2 whole square. So that is 4 added with 25 under root of 29, that is 5.38. So hence this is proved that all of these vertices we found their distance, and we can conclude that these are the vertices of a square. Moving on to question number 10. Here we have a figure of a rectangle. We need to show that these points A, B, C, and D, they are the vertices of a rectangle, and we will prove that triangle ABC and ABD form right angled triangles. How can we prove that they form right angled triangles? Well, if you draw a diagonal from the point of A to the point of C, you will notice that two triangles will be formed. So that is how you can prove that. But first we will prove the points that these vertices are of a rectangle. I actually made a mistake here. I have written A and C, but I'll take the distance of A and D first, because if I write A and C, that will be the diagonal. So by taking the distance of A and D, we will write 8 minus 2 whole square added with 3 minus bracket minus 1 whole square. After that, 8 minus 2 is 6, so 36 gets added with 16 and we get under root of 52. Simplify that, so the distance of A to D is 2 under root 13. Now we will find the distance of B and C. So the distance of B and C will be 2 minus 8 whole square added with 3 minus 1 whole square. So we get 36 added with 16 again, which is 2 under root 13. So now AD and BC, their distance are equal. So now we need to check whether the lengths AB and DC, their lengths are equal or no. And if they are also equal, that means that we have a rectangle, because the characteristic of a rectangle is the opposite sides are equal and parallel to each other. Okay, so by finding the distance of AB, we can write 8 minus 2 whole square added with minus 1 minus minus 1 whole square. So what do we get now? We can write 36 added with 0, which is just 36. So the distance of A and B, which is our length, that is 6. Okay, now finding the distance of DC, what will that be? 2 minus 8 whole square added with 3 minus 3 whole square. So we get 36 with 0, which is the same as under root 36. And we know that the under root of 36 is just 6. So hence proved they are our vertices of a rectangle. Moving on to question number 7. We need to show that these vertices are the vertices of a square. Okay. So firstly, we have a square which is ABCD, but we aren't actually have proven that these are the vertices of a square. In order to do so, all of their lengths should be equal to each other. So first we will find the distance of AB. We can write 7 minus 4 whole square added with 2 minus 2 whole square. Then 9 minus 0 is just 9. So under root of 9 is 3. After that, we will find the distance of DC. So 7 minus 4 whole square added with 5 minus 5 whole square, we get 9 plus 0. So the under root of 9 is also 3. So far, AB and DC are equal to each other. Now AD and BC should also be equal to each other in order to conclude that they are the vertices of a square. So the distance of AD is 4 minus 4 whole square added with 5 minus 2 whole square. So again we get under root 9, which is the same as 3. And then for our last point, which is B and C, their distance is 7 minus 7 whole square added with 5 minus 2 whole square, same as under root 9. So we get 3. Hence proved they are the vertices of a square. Moving on to question number 9, we need to prove that the points A, B, C and D are the vertices of a parallelogram. Okay, what is the characteristic of a parallelogram? In a parallelogram, the opposite sides are equal to each other. Okay, so firstly, we will find the distance of A and B. So that will be 3 minus bracket minus 3 whole square added with 0 minus 0 whole square. 0 subtracted from 0 is just 0. Its square is also 0. So under root 36, that will be 6. Now we'll find the distance of D and C. So 6 minus 0 whole square added with 4 minus 4 whole square. That is the same as under root 36 or 6. So far A, B and DC are equal to each other. Now we will check whether the opposite sides, which is AD and BC, they are equal to each other as well. So now AD, the distance of AD will be 0 minus bracket minus 3 whole square added with 4 minus 0 whole square. We get under root 9 added with 16 or under root 25. Simplify that, that is the same as 5. Now the distance of BC, 6 minus 3 whole square gets added with 4 minus 0 whole square. So 9 and 16 give us under root 25. Under root 25 is the same as 5. So hence proved all the points are the vertices of a parallelogram. Now our last question for the exercise. I have left some questions for you to attempt as they are your homework. If you don't understand some questions, make sure to write in the comment box and tell me what problems you guys are facing. Okay, in question number 5, we need to show that A, B and C, D are again the vertices of a parallelogram. In order to do that, we will follow the same steps as we did above, finding the distance of AB, then DC. If they are equal, then we are going to find the distance of AD and BC. If they are also equal, which means that the opposite sides are equal to each other, then this will be the vertex of a parallelogram. So finding the distance of AB, we will write 0 minus bracket minus 4 whole square added with minus 2 minus bracket minus 1 whole square. 16 added with 1 is 17. So we will write the under root of 17, which is 4.12. Now the distance of DC, which is 6 minus 2 whole square added with 1 minus 2 whole square. 16 and 1 is 17. So under root 17 will be 4.12. Now finding the distance of AD, we will write 2 minus bracket minus 4 whole square added with 2 minus bracket minus 1 whole square. So 36 added with 9, that is 45. So under root 45 is also equal to 3 under root 5. Okay, so if you look, we found the distance of AB, which was 4.12, the distance of DC, which was 4.12. They both were equal. Now we found the distance of the opposite side AD, that is 3 under root 5. Now we will find the distance of BC, 6 minus 0 whole square added with 1 minus minus 2 whole square. That is the same as 36 plus 9, 45. Under root 45 is 3 under root 5. So hence proved all are the vertices of a parallelogram. I hope you guys liked my lecture. If you did, make sure to subscribe to my channel and share this video with your friends and family. I think it would benefit them a lot. Thank you everyone.